So this is just another example of how to use Euler's method, and although this is a pretty simple example, it's a great way of showing how to apply the actual method. So if you're given the differential equation d over dx equals y, where y of x equals e to the x, and then you're also given your initial value y of 0 equals 1, and then your time step, or the change in x, h equals 1, you're going to be able to solve using the Euler's method. So if you start with x is 0, you know that you're given y of 0, and that's 1, so y is going to be 1. And then the slope is actually going to be the same because y of x equals e to the x and d over dx equals y. And then if you jump up one more plus 1, you're going to get 1 because h equals 1. And then y is going to actually be 2 because your slope here was 1, and you're going to add 1 to that. And then 2 is also going to be and then just like this one before, this is also going to be the same, so it's going to be 2. You jump up one more, that's 2. And then if you add 2 to the slope before, it's going to be 4, and then this will also be the same. And then down here, 3, if you add 4 to that, that's 8, and then 8 here. So graphing that, it's just going to kind of, if you sketch it, 0 to 1, and then 1 to 2, and then 2 to 4, 2 is at 4 up here, and then 3 is at 8 all the way up here. So that's just a rough sketch, but it shows that the Euler's method gives you kind of an approximation of y equals e to the x. And although you could use other methods to solve this and probably find a more accurate graph, this is a good way of showing that you can use Euler's method to find somewhat of an approximation of this kind of graph.